Welcome back to CodinGame, Summer Challenge 2024. And there's only, what, 2 days left to go? Hello, Amaro. How is it going? It's actually, my rank is actually much higher than I was expecting it to be. And the last time I submitted was the last stream I did, which was several days ago. And I still haven't done the racing game. So that's actually surprising. Maybe a lot of people are just not doing all 4 games. I don't know. So I think this will probably be the last stream, because I don't want to do another stream, you know, while there's only a few hours left. That always feels uncomfortable. It's a bit stressful. So yeah, this will probably be the last one. So let's just make some finishing touches. We'll see what happens. So first things first, I need to fix something. Here we go. Yeah, so I put this in just the other day. 30. Okay, so this is expected length of a game. That's wrong. It shouldn't be 30, should it? It's 30 spaces long, but you're moving roughly 2 spaces every turn, so it should really be 15. And in fact, it should even be more than that, actually, because you stumble sometimes. We'll go with 15. How's the Godot thing going? It's going alright. I have a let's see, I have a guy, I can make him walk around on the screen with the keyboard controls, and I can pick up an item, but right now the definition of pick up an item means if I walk over the item, then the sprite of that item gets copied into my inventory slot, and then the item gets deleted. So I need to do more with that, like the properties of the item and stuff like that. Have some sort of data structure for the item, but yeah, I still don't know whether I want to go for like a tactics game, or I'm actually thinking I might try to make it into some sort of use where you play cards to do your movement and actions, like a deck builder. I don't know. So we change that to 15. I'll take the bosses out. Just put some players in. I don't know, just these two. All right, so we just got to plug in the we've got a lot of logging statements I don't really want either. Okay. All right, so the racing game. We're gonna need all this stuff, so we need. See, now I regret just all this copy and pasting. This could have been done with like some sort of interface for games. And that's the correct way to do it. Whatever. Skating. Skating. So we're gonna need a skating state that comes after archery. Oh, make this bigger. There we go. So this is gonna be skating. So for skating, what do we have? Skating, it's ah. Oh, this is total spaces traveled. Okay. So we've got, let's say, dist. Risk. Oh yeah, we've got the risk factor. Funds act. Oh god, why am I changing the archery state? Just copy that. This is what happens. Oh, what? I didn't copy it. Okay, whatever. Dist. int risk int turns left int. Try and get next states. So let's read how this works. Risk order. So risk order has got to be defined as well. So for direction in directions. Alright, so for each direction, index equals, it's going to be risk order dot index. So we want to find first letter of the direction in that order, and that tells us what index we've got. If index is 0, wait, okay, so if the risk is negative, if risk less than 0, then we want to stun them for a turn. So salt equals same dist add 1 to the risk okay. All right, so that's what we do if we've got risk, if we're stunned. All right, so otherwise, we have to check the index. So here, new dist equals self.dist plus 1. New risk equals self.risk minus 1. So we just have to do this for each elif index is 1. You add 2. it's 2. You add 2, but you increase your risk by 1. And if it's 3, you risk equals self.risk plus 2. Alright, so after that, for the next 2 turns, and their risk is reset to 0. Okay, so if risk is greater, if new risk is greater or equal to 5, then we will actually want to replace it with -2. Then they'll be stunned for 2 turns next turn, but they'll still do this movement. Alright, so then we want this. So we got new dist, new risk, left, -1. Okay. Return results. So like, return that in the same format. Index, risk order. It's a string. Risk order will be a string. I think you can do string.index. Otherwise, we can change it to a list. I think it's fine as a string. You can do that, right? Yeah. So that's the state. So we've got these. We should actually put them in the correct order. This comes after archery. And then we've got this for skating. Given, so we want the probability that a player at distance 1 beats a player at distance 2, given that there are n turns left. Or we've got risk 1. I think my formula is not even using risk because it's just too confusing. Yeah. My formula is literally x1 minus x2 over root n. It's not factoring in the risk. And it should, but... Man. But we should factor in the stun, and that's easy to factor in. So it's D1, D2. Let's say weight 1, weight 2. Oh man, I've been so inconsistent with these labeling. XY, X1, Y1, D1, D2, W1. Okay, whatever. Beats player at D2. With n turns to go. All right, so this is a similar format. So it's going to be like the first formula, but it's just different. Get rid of all this. So it's going to be D1 minus D2. So if you're at if you're at a further distance, you're gonna have a higher probability. But we also want to add in this difference double twice. Okay, what's the average distance you go? So you go either 1, 2, 2, or 3. It's the same as the hurdles. So 2 is the average. So we can say plus 2 times W1 trying to remember how this first formula works for the hard hurdles now. This was X turns from the finish. I see. So here we want this one. W1 plus 2. Wait, so it's a... Having weight is a bad thing. So you want to get negative from this. So you want to say W, or just do minus 2 times W1 minus W2. So you minus the amount of stun we have, which is more than the opponent. And then this whole thing we want to divide by math.square root of n. Okay. It's a very basic formula, and it's not even using the risk factor other than the weight, because it's difficult to deal with the risk factor. I need to run trials and see what the actual averages and stuff are. Alright, well anyway. So for how long is a skating game? don't say, do they? I'll check the code. $15? It's always 15? I think so. Alright, we'll go with that. Sounds about right. But length of the game is going to be half of that, so 7.5. So it's actually shorter. That means there's less emphasis on winning the skating game because you get more points anyway, just by virtue of there being so many games. Yeah, expected hurdle gain points. Alright, so we're doing... So let's copy the hurdle. Wait, why is this to-do still here? I did that ages ago. Alright. Actually, I didn't, but I'm not going to bother doing it. It's too complicated. Yeah, expect the skating points. So D1 equals skating state dot dist and then D2 equals enemy hurdles state 0.dist skating states right, and then we got W1, it's that, that's stun. Oh, it's not stun. So it's oh, for goodness sake. All right, just get the risk factors. Risk 1 equals skate. So it's this. And then W1 is just going to be minus R1 if R1 is negative, else 0. So that's how long we wait. And then we have to do R2 is to check all these indices are correct. Okay, so that's the D's and the W's. So the probability of gold is, so this is going to be skating. So it'd be, it's going to be D1, D2, W1, W2. And this will be D1, D3, W1, W3. This one will be D2, D1, W2, W1. This is just 1 minus this, isn't it? Okay, whatever. This one is D3, D1, W3, W1. Okay, so not that. It will be N. We know it's N. Yeah, we have to do N equals one's left, and just do this little thing where we add little delta just to, so that we can still just use this formula. I didn't put N in there. So the average length of a game is 7.5. Okay, so that's, I think, the skating formula. And we've got diving, decide. So we've got, oh god, so much repetition in this. I hate my program now. If risk order is none, expected final okay, so we can replace those with skating. Nice. That is 7. See, I shouldn't be typing these in manually. It's so bad. I should have a lookup table that gives 7 for this, but come this far. I think that's all right. So it's going to be expected hurdle times archery times skating times diving. So this should all be the same. And then down here, my skating score, so it's going to be 7 and 8. And down here, so we've got to do if I equals 2, GPU equals game over, then we've got risk order equals none. My change all those. All right, my skating state, enemy skating state is none, else enemy skating state is that. Okay, this one needs to be fetched from the so it's going to need to be distance. So it's 0 and 3, 1 and 4, 2 and 5. No one else uses Reg 6. Really? Okay. Just this one. So state will be the first position, followed by the risk, followed by what is it? What's the 0 there for? Index. Oh yeah, because it trims the string. All right, so not 0. That is going to be the Reg 6. Never before being used. Okay. So then we want this. Change that to skating. Oh man. Hope that's everything. So how many points did we get for this? 2,000. Does that improve? Probably not. I mean, we're doing something for skating now. Cannot access local variable new risk where it is not associated with a value. Index should always be one of these. No, log index. What's the index? Like, how could it be anything else? One. Oh, you still need to define new risk. That was the problem. It was undefined there. Alright, it's good. I wanted it to fail here if there was something wrong with this, so it's good that I didn't define new risk beforehand. For goodness sake. Mistakes like this. That's why it's good to name these differently from the previous classes. More points. Did slightly better in that game. This new change. So our rank is 514. Done? I don't know. I can't think of anything new to add that wouldn't require completely overhauling everything. So there's only so far I could go with this strategy. And I think I've probably gone as far as I can, because at the end of the day, this just boils everything down to a simple expectation and a variance for each of the 4 games. And surprisingly, that did actually quite well, which just goes to show that these, over the course of many turns, the central limit theorem applies, and it just kind of averages out to be just a mean and a variance. But to do slightly better, like, I would need to do some sort of simulation or something, looking at exactly what, like, the next 5 turns could be some sort of branching, and that makes all this useless. So, yeah, I don't know. Let's try submitting it at least. You know, let me look at these numbers. Alright, we'll try submitting it then. Wait, I want to get rid of this logging. Who's doing that? You. Stop it. Look at these radical differences towards the end. Like here, we think if we go up, we're going to get 1,824. And if we go left, we get 1,128. That's crazy difference. Why is that? Is it because we're close to finishing one of the games and it's just like neck and neck? We are neck and neck here. Are we? You can't tell from the racing game because they've gone round the circle, so... It's strange. So we're saying up. Up would be good for the combo game. Alright. Well, let's submit it. So 514. If this does better than 514, that's it. I'm done. Like, I don't see anything else I can do. If this does worse, either we go back to submitting the old code, because it stores all your previous submissions, so, or try to fix something, or just be arrogant and submit the newer one because it's more in line with what I want it to be. I don't know. Probably just submit the old code. 842, not great, but it's the beginnings. Just climbing the ladder. Quite a few losses. Like, it could just be just not trying to do anything with the racing game was optimal after all. I don't know. Racing game is a tricky one. The diving was the surprising one. Like, adding in the diving code, that's what shot me up the board. What's with all these losses here? This is not looking good. Oh, but these guys are at the top of the ladder, so... Come on, just push past 518 and we're done. Let's see where everyone else is. Losing ranks. Well, it starts from the bottom and you climb... Well, when it reruns the algorithm, you start from the bottom and you basically keep climbing until you stabilize. So we're only like 20% of the way through the climb. So no idea where it's going to end up. We have to wait for 100% really. Like, you could even end up at top spot, even if you're this low rank in the first 20%. Right. So where's everyone else? Who was basically neck and neck with me? Where's... Oh, of course. Because the new Legend League is being released. So, like, the top 100 people or so probably promoted. DBDR is always good at these. He's always, how do we see the... Legend. There's only 43 people in the Legend League. Royal, Nanaida, DBDR. Pony Code. What universities are these guys at? Well, these are probably the alma maters. Wrocław, that is like... I think that's like the best performing university on this entire site. I've been to the University of Wrocław to present a conference before. They are a really good university for computer science, like really solid computer science department. They publish a lot of papers, so that's not surprising actually in Poland. Poland is known for having a lot of good coders. See another Wrocław. Kyoto. Wrocław. They must have a whole coding game club in the University of Wrocław. When I tried to like register for the conference in Wrocław, I couldn't even pay because the bank that I was using, they couldn't even understand the L with the line through it, which is like the w sound in Polish. But they wouldn't let me put it, and I'm like, okay, but that's the name of it. It has to be there. Otherwise, this is not the name of the university. I think in the end, I had to get my professor to pay with his credit card or something, because the bank was just like refusing to put the L like that. But then when they replaced it with the actual, like the English L, it wouldn't count. You pronounce it really good. I studied Polish for GCSE in the UK. Polish is really common in the UK because we have just so many Polish people. It's actually really useful to know Polish. Oh man, it was a tough language though. I got a D for GCSE. But I didn't really have enough lessons to really to really bring it to the same level as my Spanish or my French. But yeah, I did study a bit of Polish. Yeah, I mean, I like the sound of Polish, but the grammar, oh my god. It's tough. I guess it's similar to, well, English grammar is pretty tough as well, so probably similar to Polish people trying to learn English. Recurse. English grammar is tough, I've heard, but it's hard for me to evaluate that. But from if I've learned it natively, but I don't know. But I mean, it also, like English, French, Spanish, German, those languages, if you know one of those, it's easy to learn the other. And that's what I found when I was in school, because I studied both Spanish and French. But then Polish is like the Slavonic languages, so it's a little bit different. But if you're Russian, then you probably have a much easier time learning Polish. 665. All right, 50%. All right, I think there's a chance we'll do better with this submission. And when I was a kid going to school, like all the bus drivers were Polish, so it, like like you're better off just saying like dziękuję to them instead of thanks. All right. But this probably will be the last stream I do of this. Well, this certainly will be the last stream. I'm not going to do a stream when there's like less than 24 hours left. I never do that. I never touch this in the final 24 hours. It's just too stressful. It's like you might mess something up, or I know you got your past submissions, but still, it's just too stressful to touch this in the final hours. Come on, 599. I mean, this is just an indication. So once the deadline is over and everything's closed, they'll do a full rerun of all the leagues separately. So you can't drop a league or go up a league while you're within a league. So like if you're in gold and then they rerun everything, it's not going to take you to silver or legends. So that's fixed. But within the league, you'll be re-ranked. So everything will be recalculated and then you'll get a final rank. Usually it's roughly what you're seeing here. I mean, with the exception of like people are changing their code, but usually it's roughly what the rank looked like in the final hours. So like if you screw up and submit something with an error in the final hours, and people have done that before, then the worst that could happen is you end up with rank 861, for example, which is, you know, not terrible. You're not going to go back to Wood League. Music stopping again. Yeah, I was surprised this actually worked, because I never really do this type of approach, like a really, just like a probabilistic heuristic. Like I do use heuristics extensively, but they're always kind of mixed in with some sort of branching, some sort of try n steps, or do some sort of breadth first search along a path and like prune trees and stuff. But this was just straight up, just treating it as like an infinite sequence of random walks and taking the averages. 588, come on, you can do better. I don't want to have to submit the older code because it's sort of it's not right. It's sort of not right, but then it does better. Because it's not right to say my predicted number of points is so-and-so when I'm completely ignoring the skating altogether. That's... Still getting some wins. If I'm really close, like if I just get to like 540 or something, which is technically worse. See, look, at that point, I'm just happy to submit the new code, even though it's not. Because you can't easily compare it to the old code, because if I rerun it, I might end up somewhere slightly different. So I think if I stay here or better, then I'm definitely just sticking with that. So let's just wait for this to finish. Still got a bit to go, so there's hope. And then I can put this to rest and focus only on one programming thing, which is the code jam, which I won't do today, but I'll probably do the next session tomorrow. Today, I don't know, just play something less taxing, some shooting games or something. I think you got a great idea. I even considered trying to do the same, but I could not understand what are the meaning of the equations inside the CDF, so I just stuck to my strategy. I barely understood them as well. It's stuff I don't remember so well. You can find lots of like CDFs for common things, but I sort of had to mix that in with like having to alter it for making adjustments. Like this adjustment that I did today. So for skating, like the prediction was, and this is such a basic formula because it's not even factoring the risk in, which I couldn't think of a way to handle risk, so I ignored risk altogether. But it comes down mostly to d1 minus d2, which is saying if your distance is greater than d2, then you'll have a higher chance of winning. But then my formula on paper was missing the stun bit, so I had to like add that in, like on the fly while I was coding. So I figured, okay, we have to factor this in, but because hang on, I don't think this is even the right way around. No, it's okay. Yeah, this is right. So if player 2 has more stun than player 1, you would expect player 1 has a higher chance of winning. And if player 2 has more stun, then W1 minus W2 will be negative. Negative, that will be positive. So we're adding in a positive amount if W2 has more stun. And we're multiplying by 2 because we're saying being stunned for 1 turn is basically costing you 2 turns of progress, because on average you move 2 spaces per turn. Sorry, yeah, it's costing you 2 spaces. Yeah. And then the root n doesn't matter so much. What that matters really is the order of magnitude. So it's supposed to be root the number of turns, because in a one-dimensional random walk, the variance is root n or something like that. And if you go up to 2-dimensional, then it becomes 3, like n to the power of 3 over 2 or something. And then when you go into 3 dimensions, it becomes like n to the 5 over 2. I can't remember this. It's like if you study Markov chains, there's some patterns for different dimensions. But in the one-dimensional number line, you get some interesting results from that. Like, if you walk randomly on the number line, you'll always eventually reach your starting point at some point. Even if you just go off in some random direction, you go really far. Eventually, there is a probability of 1 that you will return to your starting point. An infinite number of times, even. In 2 dimensions, that's still true. So if you start somewhere in the grid and you take random steps up, down, left, or right, no matter where you end up, there is a positive probability 1 that you will actually return back to the start. And that's not that intuitive, because it's like eventually things spread out and it doesn't seem likely, but it is. Now when you go to 3D though, that's no longer true. You actually get lost. There's a non-zero probability of getting lost permanently and never ever returning to your starting point. What was that? What's that even called? It's called like the hitting probability or something. Yeah, it's all stuff that comes about when you study Markov chains. Okay, 486, is that it? Still going, just a little bit more. No, I think it is actually finished. Just trying to think if there's any little slip up I've made that could be fixed. Like I thought I just saw one there, but no, that's the correct way around. Chains of Markov. Call your game that. My game has nothing to do with Markov chains. Well, I haven't even decided what my game's about, so it could be. Oh my god, the amount of repetition I did in this. Oh really? It's only 359 lines? Just felt like way more than that, but... Okay. Oh, one thing I should check if there's any errors. Unfortunately, they don't have... Like, it'd be really nice if they had sort of like an exclamation mark or something that told you actually got an error in that game. But I guess... I don't know, they don't. So the only way you can know... Oh, it dropped down to 500. Whatever. The only way you can know really is just looking at each individual game. And if you look at this, if there's any colored bars, that means that guy got an error. And there's no bars, so nobody got an error. So if you look at the ones you lose, because if you get an error, even if you have more points than your opponent, if you get an error, even if it was like towards the end of the game, you just instantly lose. And they win, I believe, or at least that's usually the case. So errors are, you know, will absolutely destroy you. So, like, sometimes you just got to have a look through your losing games and check if there are any errors that caused that. And if it's not happening, if you don't see it happening, then you know it's probably, if it's happening at all, it's probably happening with such a low probability that it doesn't matter. But yeah, still good to check. From the conversations on the Discord, it looks like that many people doing Monte Carlo tree search simulation. Right, yeah. It would have been an interesting thing to do. Like this, my intention with this was literally, it would just be a fallback. Like, use the base probability to work out how good a state is, and then I would actually do some sort of Monte Carlo search or something and fall back to this estimation as like the base estimation. But I reckon in the final turns it's just much worse, because the whole point of this is that it's more accurate for longer sequences. But then when you get into the final turns, there's only 5 turns to go or something. Like then, and some moves could be critical. Then, you know, assuming you have an infinite sequence is a bad assumption, and this is probably giving me bad moves towards the end. So like you could do a Monte Carlo search, and you could say, as time goes on, you weight the probabilistic thing less, and you weight the Monte Carlo search more. I don't know. So it could just be like a linear sum of the two, where the quantity shifts, something like that. I actually always fail on really deep simulations. I can simulate a little using BFS, DFS, and stuff like that, but doing full search with heuristic function is out of my reach. Well, no one really does full search. If by full search you mean like checking every possible branch, because they're just... You can do full search within one game, though. I mean, if there's only 10 turns to go, then yeah. Then you can actually full search that one game. Yeah. So it's not like anyone else is managing to do full search. They're always pruning. No, I mean good scoring function is tough for me. Yeah, that's That's a tricky one, and usually the crux of an A-star search, right? The difference between A-star search and Dijkstra, isn't it? Having a good heuristic. Alright. Looks like 500 is roughly where I end up then. I'm still ahead of Ku, but I think Ku is doing some changes, so he'll probably jump ahead again. Okay then, I guess I will go finish the stream, and I'll probably come back in like 5-10 minutes. Just play some shooting games or something, because my brain needs a rest. I wanted to play that puzzle game, Isles of Sea and Sky, but my brain is not ready for that. So, thanks for watching, and I'll have to upload the footage to YouTube as well, because apparently these streams get a lot of views. Particularly the Advent of Code ones. Okay, that's it. Thanks for watching. See you in... The next major competition I'll be doing will be either the Coding Fall Winter or Advent of Code. Both usually happen in December. It's just a question of which comes first. Last year they were basically in the same weeks. So yeah, probably see you in the winter, unless some other competition takes my fancy before then, but none that I can think of. It's CodinGame and Advent of Code are really the two that I would actually bother streaming. So, see you in the winter. Bye bye.